Hello everyone, welcome to our channel Code with Sunny, and today we'll be discussing this third problem of this Google Kickstart round D 2022, which is touch bar typing. Okay, so this problem is quite simple, that it involves dynamic programming. Like you need to know either like you need to know how we are going to find out move out from one position to other, and just we are going to memorize the solution. And also I need to ask, if you haven't subscribed to our channel yet, I will ask you to do that, because we are going to upload a lot of useful content uh, in the incoming days. Okay, so that would be beneficial for you if you are doing competitive programming at DSA. Okay, so let's talk about this problem, how we are going to use the concept of dynamic programming to solve this problem efficiently. So let's start. Glide typing task is a crowdsourced app, uses a Google keyboard to type a word, sliding a finger across keys without lifting the finger. So to make the glide typing task more challenging, instead of a normal keyboard, we have a special linear keyboard K that has all the keys in one row. Imagine that you want to type a word S that is n characters long. So there will be a string S that is having the length as n. The linear keyboard K which has m keys, that is you'll be having the array K which has the size m. Note that this word S is not a string; it is actually a integer array which is having the size n. It is guaranteed that the keys cover all the characters in S. It means that if you have the some certain integer in this string, in this array S, then that integer is also present in this keyboard K, because we are going to type that integer using that keyboard, then obviously that integer must be present. However, some of the keys may be duplicates, like there exist one or more occurrences of a particular integer in the array S. In the if you have some integer, let's say x, in this array S, then there exists one or more occurrence of x in the array K also. In other words, for each character in S, there is one more keys in K mapped to the character, as I've already said. Note that all the characters and keys are represented as integers. This is not a string S and this is not a string K. It is basically denoted as integer array, by an integer array. You may start with your finger on any key. It takes 1 second to move your finger from a key to an adjacent key. Due to glide typing, there is no pressing a key. If the finger is currently at the key I, which has the character ki, and we want to type the character kg at index g, we will glide the finger from key I to j, which takes j minus I seconds. If your finger is at key x, you can type character kx any number of times instantly. You need to type string s character by character. Formally, you need to type si before si plus 1 and so on, and calculate the minimum time needed to type the word. Okay, so let us understand this problem with the help of an example. So suppose we are having a integer array S which is of length n, which will be S0, S1, S2, and it goes up to Sn minus 1. And we have the you know array K which is of length m, which will be K0, K1, and it goes up to Km minus 1. So the problem says that you need to type each character. Let's say we are going to type S1, then you need to find out the position, find out the occurrence of S1 in this in this array K. Like there may exist one or more occurrences of S1 in this array K according to this problem statement. This is actually keyboard. Okay, so there doesn't exist exactly one occurrence. There are one or more occurrences of the character S1, and it is also said that for each distinct characters present in S, there exists exactly there exists exactly at least one occurrence of that distinct character in this keyboard K. So you need not to worry about what if we are going to access some character Si and that occurrence is not present in this array K. This is not going to be possible, okay, according to this problem statement. So let me take an example and just show you how the things will work. So suppose we have an array 1 2 3 2 1. and we have another array. This is array s of length n, and we have another array 1 2 1 3 1 2 1 3 1 2 1, and this is the array key. Okay, now you can see that for each occurrence in this array s, we have at least one occurrence of that integer in the array key also. Suppose we are looking for one, you can see one is present over here, here. And similarly, if you look out for this 2 is present. Like the occurrences, number of occurrences are more than one. Like at least one. You can also have exactly one occurrences. Okay. Now, if you need to type one, you can type one from here, you can type one from here, you can type one from here, one from here, or from one from here. Like from any of these positions you can type one. Okay, now let's say we are going to type one from this position. Okay, now this one is being typed. Now you need to type this character 2. Type it. Okay, now you have started typing the characters from this position. Now you need to type this character, you need to type this integer 2. So you need to either move out to the next position, like you need to move out to the occurrences of 2 from this position. Now occurrences of 2 are over here, or to this position, or to this position. There exist exactly 3 positions from where you can move to the next demanding character, which is 2 over this position. Okay, now just tell me which character you will, like which position you will try to move from the current position. What will be your next position? You will always try to move out to the next closing position in the left side or to the right side. Okay, you can see this is the minimum position than this one with respect to the current position. Okay, so let's call this as n1 and n2. These are the new positions. You need to move to, first you need to determine what is the distance between n1 and the current position. Similarly, n2 and current position. If this value is minimum, this value is lesser than this value, d1 is less than d2, then you will move to this d1. Otherwise, you will move to this d2. In other words, you will try to move out to the first occurrence of this character 2 to the right, as well as you need to move out to the first occurrence of this character 2 to the left of the current position. Okay, so it is always optimal to move to this n1 position rather than going to n2 position. Okay, so you will always try to move to this n1 position, and for this position you will always try to move to this position. Okay, so when you are able to find out the next moving position, you will try to move out to that position, and you will try to you will try to type out all the remaining characters. Okay, so you can see, let's say we are going to move out to this position. Okay, so this will be a new position dash, and you have already typed, and cost of moving to this position, like from position to position dash, will be 1, because their distance is 1. Okay, now your new move will be find out the next possible position of this 3. You can see 3 is present over here and 3 is present over here. Okay, you need to check out for all these 2 possible positions. You are going to check out for this one, and you are also going to check out for this one. Note that for the previous 2, you can also explore the left possible position, which is this one. Like from this I have moved out to this one. You can also move from 1 to this position. This may give you the minimum score. I think we need to find out the minimum. Yes, minimum time. Okay, so for every position, like your current position is I, like you are going to type this ith character, and you are currently at this jth position. Okay, you are currently at ith, you need to type this ith character, and you are currently at jth position. Okay, so you need to check it out what is the least wait a minute, it's someone okay, so you need to check it out what is the next possible position of this ith character to the left of it and to the right of it, and if you are able to find out, you are going to move out to typing this next character I plus 1, and your new position j will be this some position of this one or some position of this one. Okay, plus you need to add up the cost of moving to that cost, and then you are going to move out to a next position I plus 1. You need to type out for the next character, and your next position will be either this one or your next position will be either this one. Okay, now you need to know efficiently how do we find out the new position, next positions with respect to the current position. If you are at 3, let's call it as 3. Okay, and you need to know that what will be like, you need to type out this character 3, and you're currently at this position. Let's say you're currently at this position 2, and you need to type out the character 3. You need to find the next position of 3 to the right of it, nearest position of 3 to the right of this 2, and similarly nearest position of 3 to the left of this 2. How do you find that? You need to pre-calculate this in these indexes using dynamic programming. For each unique occurrences of the key, you need to find out the least position to the left of it where it has occurred, and similarly for the suffix side also the least position where it has occurred. So if you're not getting it, no need to worry about. Let me just tell you with the help of example. Suppose you have an array like 1 2 3 1. Okay, so there are exactly 4 positions. What I am just telling it is for the prefix side, what is the least position where it has occurred to the left of it. So this is position 1 2 3. Okay, and this is for the character 1, and this is for the character 2, like integer 2, and this is for integer 3, and this is for integer 4, which is not over here. So this is position 0, this is position 1, this is position 2, this is position 3. Let's fill all those values with -1 for now. Okay, so I'm not going to fill it and show you. So for the position 0, you can see for position 0, 1 is going to occur over here. So I will write down position of 1, like key 1 is appearing at this position. I will fill it out with 0, and key 2 is appearing at this position 1. So key 2 is appearing at this position 1. I will write 1 over here. Key 3 is appearing at this position 2. So I will write down this 2 over here, and similarly key 1 is appearing at this position 3. Okay, so key 1 is appearing at this position 3. So I will write down 3 over here. So what is this? Like when we have been asked that what is the position of the 1, like when we are at this position, let's say position 2, what is the nearest position of 1 to the left of it, which is this one. Okay, so how do you calculate that efficiently? Okay, so if you find out the prefix version of this character 1, then you can easily tell how many distances you need to move from this position to this position to get the next integer as 1. So you will have to do the prefix version of this character of this integer 1. How we are going to do that? So let's track out the latest integer that we have at this current position. Latest integer that we have at this current position is 0, so we will fill 0 over here. Now here doesn't exist any character, but previously latest integer that we have tracked is 0, so you will fill 0 over here. Similarly 0 over here. Now the latest integer becomes 3. Now if you have some certain entries also, you will fill up 3 over here, because latest integer that has occurred to the left of this current position, this is the current position, to the left of this current position, which is 3, then that's why we are going to fill out this 3. Okay, and similarly for the character 2, like this character 2 has not appeared over here, so you will write down -1. Now the latest entry of this character 2 occurs at this position 1. You will make a variable holding the position 1 as your current tracked position. Now when you move out to the second position, you can see the latest position of this 2 which has occurred previously is 1 at this position. Similarly at this 3, latest position of 2 that has occurred previously is 1. Similarly, you are going to write down minus 1, and from 2, you are going to write down 2 over here. So what is the advantage of this one? Suppose you have this one 1, 2, 3, 1, and you are at this current position. Okay, and you want to move to a position which contains the value 1. So you will start searching in this column 1 and at the position 2, that is at this position. Okay, and it sees the value is 0. It means that latest position of 1 to the left of it is actually this one. You can get that in O of 1 time. And if similarly, if you maintain the suffix version of this table, suffix version, you will get the latest position of 1 over here in O of 1 time. And this is the position where you have to move for the, like you have to move to the next position. Okay, so yeah, if you are able to find out this next position, you can use recursion, then you are going to memorize that. Okay, so our states would be like you are currently at position I, where I varies from 0 to n minus 1, which is for the integer array of integers s, and similarly you have j, which varies from 0 to m minus 1. Okay, now what you will do, you will solve for I comma g. Like what you need to type the character I, and you're currently at this position g. Okay, so you have to move to the next position such that it contains the character that is present at the position I. You're going to type it, and then you're going to move to the next positions also. So this is our basic demand, and you're going to memorize the solution using dynamic programming. You're going to maintain a 2D DP table. DP of ig will denote minimum number of moves you are going to take, minimum amount of time you are going to take to type the current character. So let's look out the solution, how we are going to implement that efficiently. Okay, so I have taken this max as 2505 because max of n and m is 2500. So I have taken s and k as max size plus 1, and we have prefix and suffix versions. Okay, so first I have taken the array of integers s, similarly the array of integers m. So let's find out the maximum element that is present in this k. So up to that maximum element, we need to build up this prefix and suffix versions. Okay, so I will iterate in this prefix and suffix version, and first fill out the default values, which is -1. Then I will iterate for each of this integers present in k, and I will initialize this prefix of I and s, prefix of I ki and suffix of I ki as I. That is the current position. Then we need to fill up the prefix and suffix versions for each column, that is going to vary from 0 to the maximum element. So let's keep the last tracked position of this current integer. Okay, so we will iterate for the prefix side, and if the value is not equal to -1, we will get our new position, and we are going to assign our new position to our current prefix of ij will be exactly equal to the last. It will denote that jth, like it will denote the integer j which has occurred, like the latest position of j to the left of the position I is the last will hold that value. Similarly, we are going to do for the suffix side, and if we are done, we are going to iterate for each position in the range 0 to m. We can start from any position actually, like as I've already said. If you look out this one, yeah, we can like to type 1, we can start from any of the positions, like we can start from 1 as it is, you can start from 2 as it is. Okay, and if you start from 2, you need to move out to the latest position of this one and type it. Okay, so we will start from any of the position G, and we are going to find out this min cost typing. So if I reaches n, we are going to return 0, and if we have already worked upon that table, if dp of ij is not equal to -1, we will return this dp of ij. Otherwise, let's find out the current cost to type the character. Okay, so like we are at the position J, and we need to type this ith character, right? So you need to find out the occurrence of ith character to the left of this current position and to the right of this current position. So we will check if prefix of j is the current integer, and s of I is the character that you need to type, is not equal to -1. It means that the current integer s of I is present to the left of the position j. It means that yes, you can move out to this that position and you are going to type it. So cost of moving to that position is j minus prefix j si, and you are going to move type out for the next character and minimize your answer first. So answer equals minimum of answer comma cost plus min cost typing of, you're going to move out to the next position I plus 1 to type the next character, and prefix jsi will be your next position. Okay, and this you're going to pass the dp table also, and similarly you're going to do for the suffix side, and yes, you're going to memorize the answer, yeah, store the answer in dp table. So this will give you all test cases passed. So if you guys have still any doubts, you can reach out to us through the comment section of the video, and thank you for watching this video, and do not forget to subscribe.